All right, well, let's get going. So, welcome everyone to today's conversation about one of the most critical challenges facing the space industry, transitioning from a small production to mass production. So, I'm Ben Rouget, and today I'm joined by two exceptional guests. So you've got Iain Christie and Jeremy Perrin. Iain is a seasoned executive in the aerospace industry, was previously the CEO of Neptech Design Group, a company acquired by MDA, the executive VP at the Aerospace Industries Association of Canada, and today he works with and mentors hundreds of startups with his work at the Creative Destruction Lab Accelerator. Jeremy is the CEO of Connectica, the company on a mission to digitize and automate manufacturing for aerospace SMBs. And so far, more than 100,000 flight parts are in orbit, have been assembled, integrated, and tested with Connectica. Before we get started, two important pieces of information. One, you will have access to the recording after the webinar if you want to share it with your colleagues. And two, the Q&A section is open. Feel free to use it. We may not be able to get to all the questions if there's many, but we will get back to you after if we don't have the time to answer all your questions. Now, let's hear from Iain and Jeremy.
Thanks, Ben. Jeremy, we got a lot of interesting things to talk about today, but before we dive into that, I've known you for about 5 years, really, since you were starting Connectica. And so I want to point out that the problem we're going to talk about today is one you've been thinking about for a while. And maybe can you just talk a little bit about how you got started with Connectica and what was the problem you were trying to solve when you started the company?
Mhm. Yeah, thanks, Iain. So my journey founding Connectica began after working as an engineer for Prime in satellite industry. I was at that time responsible for testing complex RF system and saw immediately the disconnect between the prototype world and the mass production. And we had very smart engineers who could build and test one of prototype, but when we made it the scale production for actual deployment, everything fell apart. So documentation existed on project drives, test procedure were in someone's head, and there was no standardized way to transfer this knowledge to the production team. So after experiencing this pain point across multiple projects and seeing other companies struggle with the same issue, just realized there was a fundamental gap in how space industries approach manufacturing. They had plenty of experts who could build amazing one-off satellites, but very few who understand how to scale production efficiently while maintaining the reliability requirement of space. And that's what led to Connectica, actually, a platform specifically designed to bridge this gap between prototype development and mass production in a highly reliable industry like the space manufacturing.
Right, right. I can see where that, and at the time I could see where it was coming from. I mean, this is 5 years ago. The distinction that you're talking about really only became important maybe 10 years ago when the space sector suddenly began to open up to a lot of smaller, lighter satellites, and production at scale began to become something that space companies needed to worry about, which they hadn't up until then. What are some of the fundamental differences, though, between the legacy style of which was prototype development, and mass production, which is now what space manufacturers have to deal with?
Mm-hmm. Yeah, Ian, remember a specific moment that really crystallized this for me. I was called to help troubleshoot a production issue where units were failing a specific RF test in production. And when I started to look into it, it discovered that during prototyping, the design engineer had encountered the exact same issue, and they solved it by making minor adjustments to the test procedure on the engineering model. But that knowledge never transferred to production. So they were effectively rediscovering the same problem months later. So the fundamental difference are really about mindset and processes. You have two worlds. In the prototype world, we're focusing on validating that the design works and matches the simulation. So engineers are hands-on using Excel spreadsheet, Python, MATLAB script, and a lot of manual processes. And there is a lot of iteration and troubleshooting in that way. Mass production is an entirely different environment. You can't rely on your top engineer being involved in every build. You need standardized, repeatable processes that even less experienced operator can follow consistently. And this is typically the biggest underestimation I can see. It's also the disconnect between these two worlds. So the company often fails to capture critical knowledge from the prototype phase and transfer it to production So if an issue that appears 2 years into production, it might have already been discovered during the prototyping. But the problem is if that knowledge wasn't properly documented and transferred, your production team is going to spend valuable time to rediscovering something that was actually already known.
I bet there are people in the audience who are sitting there thinking, boy, I wish I had no idea what he's talking about. So, when we met about 5 years ago at the Creative Destruction Lab, when you're going through the incubator, this shift to new space was really just starting to have an effect. It had been going on, but it was really starting to become obvious. And there were a lot of new customers, new investors in the market who were expecting to be able to, frankly, build large constellations of small satellites, which was going to have to be done at a much lower unit cost. And scaling production that rapidly was becoming an issue, whether everybody realized it or not. And that was the one that you were sure, that issue of being able to scale production at a reasonable cost, that needed to be solved in a new way. It wasn't going to be an incremental change. And I was impressed by that you realized that. And I think it's fair to say you've probably spent more time thinking about that and trying to solve that problem over the last half a decade than pretty much anybody else I know. So let me ask you this. Based on your experience across multiple deployments, getting lots of equipment actually on orbit that works, what are the top three bottlenecks in the production process that anybody's going to face when they make this transition?
Mhm. Uh, when I was working with one of the leading satellites manufacturer, they had just received a contract to build flight parts for more than 30 satellites, which was around 10 times more than they have ever built before. And the first instinct was just, okay, we're going to hire 10 more time engineer and technician, but that approach totally failed. And that's what really made me realize how common these bottlenecks are across that industry. So regarding the main bottleneck, the first major bottleneck is clearly visibility and traceability. The production directors, they need real-time insight into what's happening across their operation, including at their supplier sites. And without that centralized data, they're making decisions based on outdated information. I've seen many times production meeting where the data being presented was already a week old, so completely useless for making timely decisions. The second one is probably the reliance on highly skilled personnel. Traditional space manufacturing depends on very specialized engineers who understands the particularities of each component. The problem is when you scale, you simply can't staff your entire production line with this expert, just not sustainable or cost effective. And for having implemented this type of solution across more than 10 different manufacturers, this is really the bottleneck that appears consistently regarding the size of the company, actually. And the third one, I will say, probably the disconnect between the design and testing phases. In traditional workflow, these are separate worlds with different tools and data format. The problem is this creates a slow feedback loop and delay iteration and optimization of the design. And when scaling this production, these disconnects become magnified and significantly impact your ability to improve your processes.
Yeah, I mean, things really have changed in this business since I was building sensors for the space shuttle. At that time, we had, very different approach. I mean, I remember a time when every RF measurement curve was not only manually reviewed by one of our engineers, but one of the customers' senior RF engineers as well before they would approve the component. We can't do that anymore. How has the industry's approach to manufacturing changed over the past decade? Particularly this shift from highly customized, customer approved parts to more standardized parts that can be approved in batches and lots.
That makes me smile. It's such a familiar scenario, Iain. Like, by example, I remember one company I worked with where the most senior RF engineer was spending 70% of his time reviewing test curve rather than designing new system. It was a colossal waste of expertise, but they didn't have the system in place to automate that verification. And even if they did, they were missing the confidence in the automated decision making. So we've seen a dramatic evolution in the space industry over the past decade. Traditionally, everything was over-optimized and custom built, which created tremendous quality, but at a massive cost and time investment. The new space approach is fundamentally different. Right now, the companies are now moving towards standardized component and commercial off-the-shelf parts wherever possible. And this shift requires different production approaches. Instead of the traditional V-cycle, with lengthy design phase followed by manufacturing at the end, we're seeing companies adopt design for manufacturing principle from the beginning. So that's mean about how components will be assembled, tested, and integrated during the design phase. Are these features need robotic handling, for example? How sensitive is the designs to manufacturing tolerances? And these considerations become critical when you're producing thousands of parts instead of a few. One thing I've seen constantly in my deployment is what I call the DCs of vertical integration. Space companies trying to do everything themselves rather than focusing on their core competencies. And this actually creates additional challenges as they try to master areas outside of their main expertise, including manufacturing processes.
I couldn't agree more with you about the whole vertical integration problem. But don't get me started on that soapbox. But I think the point of this is that, I mean, this is in some ways, after you've been involved a little while in the last 10 years, it's a pretty easy problem to figure out that we had. But it hasn't been an easy problem to solve. And that's probably the thing that people who really haven't had to solve it haven't figured out yet. That this is not as straightforward as it sounds like it should be. So after having worked with multiple companies in the transition, what have you found are the essential capabilities that manufacturers should be looking for when they're building a modern assembly, integration, and test solution for space parts?
Yeah, you're totally right, Iain. Identify the problem was actually the easy part, but solving it has been much more complex. After implementing across multiple companies, we identify several critical capabilities that typically make or break success. So remember working with companies that had invested millions in separate systems for manufacturing and system and testing, only to realize they couldn't correlate test failure with assembly methods. And this creates slow feedback loop that delay iteration and optimization of the design, as the system could not be used for the first breadboard unit received. And it was a very costly lesson that really shaped my thinking on what is truly essential. So first, maybe any solution must be integrated. The biggest pain point in scaling production is the disconnection between assembly and testing data. When these live in separate systems, you lose the traceability and the ability to correlate test failure with assembly processes. Second, it needs to be user-friendly. Your solution should be accessible to operators with different skills level, not just your top engineers.
Right.
And this is very critical when scaling because you are going to bring more and more personnel who aren't necessarily space manufacturing experts. Right. I've seen companies struggle with adoption because they choose a very powerful but complex system that the floor operators simply refuse to use. Right. Yeah. Third, it must offer real-time visibility. Production directors need dashboards that show what's happening across the operation without manually consolidating data from multiple sources. By the time manual reports are generated, they are already outdated. Fourth, I would say, probably look for flexibility in automation. You want a solution where you can start with manual processes and gradually automate steps as you identify optimization opportunities. And this allows you to scale up automation in areas that provide the greatest return first. Right. And finally, I would say it must maintain a rigorous compliance. Space manufacturing has strict quality and documentation requirements. So your solution needs to automatically generate the documentation required for compliance, but without adding any burden to your team. And most companies will only go through this transition once on their life. So learning from tools who've done it multiple times can save a huge amount of time and costly mistake.
Yeah. I mean, what you're saying is this isn't just automating something. There's a lot more to it than that. I like the way you describe it as a unified assembly, integration, and test platform. You mentioned that data visibility and traceability are critical challenges. I can certainly attest to that. Based on your deployments, how does this system, a unified AI&T platform, how does it address those issues in the way legacy approaches can't?
I actually learned this lesson the hard way at one manufacturer where we had a satellite experiencing intermittent issue during the final testing. And it actually took weeks to trace back through disconnected system to discover that the component has been briefly exposed to excessive humidity during assembly. That was something recording in one system, but not linked to the test data in another system. So legacy system typically consists of disconnecting tools for different parts of the process. You might have a manufacturing executing system for assembly steps, separate test equipment software, and various data collection methods around. But this fragmentation just creates significant data silo and blind spot. So a unified platform, it provides end-to-end traceability by design. When a test fails, you can immediately trace back to see which components were used, who assembled it, which workstation was involved, and what the environmental conditions were. And it's this complete picture. It's just impossible with disconnected system. So real-time visibility is another game changer. With legacy approaches, production directors often learn issue day after they occurs. With a unified platform, it gives them dashboard showing current status, bottleneck, and trends as soon as they emerge. And this allows for much faster intervention when problems arise on the floor. We tell that another critical advantage is the preservation of context. In legacy system, you might capture that a test failed, but miss what we call the metadata around it, like the operator comment, the calibration status of an equipment, or all the environmental factors around it, the humidity, temperature, pressure, etc. And unified platform, it captures all this context automatically, which is really invaluable for troubleshooting and continuous improvement. So in the space in manufacturing, your reputation is really your only real moat. Having this level of traceability doesn't just improve efficiency, but it directly impacts your ability to build trust with customer and respond confidently to quality concern, actually.
Yeah, I apologize. I keep having flashbacks when you talk. I'm having a little bit of PTSD here when you're talking because all the situations you're describing are ones that I actually came across, in the legacy mode. And absolutely, not being able to have that traceability was a major cost driver. I wish I had a dime for every hour I spent in the room with NASA program management trying to convince them that we knew what the problem was. And it was the documentation and the traceability visibility that allowed us to do that. And only when we had a reputation for knowing what we were doing would they start to trust us. We had to fly, and we had to be part of their missions before they would grant us that trust. So, as you say, our reputation was our competitive moat. So, why is having an integrated solution for both production and testing so important to this whole process?
Mm-hmm. Yeah. Again, like I once worked with a manufacturer who had built, let's tell, 20 identical satellites. And we have two of them that were consistently showing different performances characteristics than the other one. And it's only after weeks of investigation that we discovered that these two units had been assembled using a slightly different procedure. But because the assembly and test system weren't integrated, no one have been able to make the connection. So all that to say that this integration is absolutely vital because assembly, integration, and testing are inherently connected processes in space manufacturing. In the traditional approach with separate systems, we lose the relationship between how something was built and how it performed.
Yes.
So the integration is actually absolutely vital. And when production and testing data live in the same system, you can identify correlation that would otherwise be invisible. Like perhaps unit assembled on Tuesday consistently show different test results than those assembled on Wednesday. But without integration, this pattern might never be discovered.
Yeah.
So to come back to integration, it's actually also dramatically improved the feedback loop between testing and design. So when test engineers discover an issue, they can immediately access the complete assembly history. And this naturally speeds up the root cause analysis and enables them for faster design improvement. For the companies scaling production, this integration supports knowledge transfer. So the insight from the testing prototype units directly inform production procedures. And the best practice can be immediately incorporated into assembly processes based on test results. So it's really an iterative process. And finally, integration significantly reduces overhead and human error, which is one of the big issues when scaling. Operators don't need to manually transfer data between systems or re-enter information, which is going to eliminate a major source of mistakes and efficiency when scaling.
Yeah, I mean, I'm thinking back to when I had to do this, and the way we solved that problem was literally that the people who designed the thing and built it also tested it. So the integration was in somebody's head, and there's no way you can do that at scale. And I think that's been something that legacy companies have really had to realize, that that they need the same information in 3 different places, but it can't be the same person. So that integrated part, I think, is something that's really important to this and might kind of get lost because everybody thinks the modern thing is about automating everything. The way to make things faster and cheaper is automation, which is part of it. But I think, I think you'd probably say that the automation is something that doesn't have to all happen at once, right? You can, so long as you get the integration right, the automation can happen by stages. And sort of what's the priority to automate when you're doing
Mhm. Yeah, but let me share a quick story that really drives this home. Again, when I was working with satellites manufacturer, where operator was manually copying test results from equipment display into spreadsheet, and we find they were spending 40% of the time on data entry, with an error rate around like less than 5%. And just automating data collection immediately boosted productivity and fixed this error. So automation is incredibly important, but it should be approached strategically rather as an end goal by itself. The question isn't whether to automate everything, but whether where automation deliver fast the most value. So companies should prioritizing automating data collection first. Manual data entry is not only time consuming, but extremely error prone. So let's get rid of that first. Then automated data collection from test equipment, sensor and manufacturing tools provide an immediate return by reducing error and freeing up personnel for higher value tasks. The second one, that probably should be the test execution. Automated testing ensure consistency and remove variability introduced by different operators. And it's also going to allow for more comprehensive testing without extending timeline. Third, probably focus on automating report generation. In space manufacturing, documentation requirements are extensive, and automatically generating compliance reports, test records, and traceability documentation save enormous time and ensure nothing is missed. But on the other hand, I will caution against trying to automate assembly processes too early, because this often requires substantial investment and can be difficult to change if product design evolves. So start with this data-focused automation that deliver immediate value while maintaining the flexibility.
I mean, we know compliance is crucial in aerospace, not only space, but aerospace. But I think what people may not appreciate if they haven't worked, especially for really large established customers like government space agencies or other large space companies, is that compliance isn't just about delivering what you say you would. And being able to prove it, but particularly it's being able to prove it when the integrated system doesn't work, which it often doesn't. There's going to be multiple suppliers who've supplied multiple components, all of which are stuck into a package that has almost no margin or even negative margin in size, weight, and power. And there's no way for anything not to affect everything else. So I think maybe people don't appreciate how important compliance documentation is, because you can prove to your customer that you're not the one generating the problem. Because if they don't believe that, they're going to expect you to go back and do a whole bunch of testing to prove it to them, which is going to cost somebody money. So how important is it to really make sure that your AI&T process generates documentation, not only for you, but that your customer will believe ensures that you are compliant?
That's so true, Iain. Remember working with company that failed an audit because they couldn't produce consistent documentation across the production line, and despite having done everything correctly from a technical standpoint, but it totally damaged the reputation and it delays the program significantly. So the compliance, clearly, it should be built into your processes from the beginning. It should not be treated as a secondary consideration. When we're working in aerospace, whether you're following the EN 9100 in Europe or IS 9100 in the US, these standards aren't designed for efficiency. They're designed for quality and safety. So the key to scaling while maintaining compliance is automation of documentation. Every step, every test, every non-conformity should be automatically logged as part of the normal workflow. This means operators don't perform extra step for compliance, but the system captures everything they do naturally. So the company should also implement role-based access control and electronic approval to maintain the rigor of the process while scaling. And this is going to ensure that only qualified personnel can perform certain operations and provide clear accountability. And another critical approach is competency management. Your system should automatically verify that operators have the required qualification before allowing them to perform a specific task. And this becomes increasingly important as you add more personnel during scaling. And finally, I will centralize all compliance data. Like when an audit occurs or a customer requests documentation, you should be able to generate complete reports with a single click rather than collecting information from multiple systems, etc. So this not only saves enormous time, but it's also reduces the risk of incomplete documentation.
Yeah, a few things occur to me when you say that. First is that all those standards should come with a warning stamped on the front. This standard is not designed to ensure efficiency, because that's absolutely true. And the second thing is I often say, and have said for a long time. I mean, I'm doing this for 40 years, and I've said for a long time that in the space business, amateurs talk about technology, professionals talk about process, because it doesn't matter how high tech your solution is if you can't prove to people you can't. It's not enough to prove it worked last time. You got to prove to people it's going to work this time, and that is part of the way you do that is by not only having the processes, but prove that it's impossible for your people not to follow them. Because the reason processes are there is because they make people do things they wouldn't otherwise do. If it was something people did naturally, we wouldn't need a process to ensure we did it. So making all of the things you're describing really lower the overhead of getting people to do the thing that isn't natural, but that's absolutely essential to building that reputation as somebody who can build trustworthy stuff. So, okay, enough about that. Uh, for an established manufacturer that suddenly needs to scale up production to meet new contract demands, I mean, how do you do this without disrupting, what is already an ongoing business?
Yeah, I've been in this situation with several clients. For example, one aerospace manufacturer had been building 5-10 units per year, and suddenly they receive a contract for 100 units annually. So their first instinct was just to scale everything up proportionally, but that approach quickly fell apart. So we found that the highly manual processes simply couldn't scale, and the most experienced engineers were becoming the bottlenecks. So the key insight was they needed to transform their processes, not just growing them. So for an established manufacturers that already have legacy system in place, I will recommend a parallel implementation approach. Start with a small, contained proof of concept on a project you're already familiar with. Run your unified solution alongside your existing processes to directly compare result, efficiency, and cost. And this type of approach lets you validate the benefit without disrupting ongoing production. And it's also going to help identify integration point with your existing system and highlight any processes adjustment needed before the full implementation. So having deployed this system multiple times, I can tell you that finding the right champion within your organization is very crucial. You need both management support and buy-in from the floor operator who will use the system daily. And involving both groups from the beginning ensure the transition addresses real needs rather than just theoretical improvement. So once your proof of concept demonstrates clear benefits, expand gradually to other production line or to other product families. And this phase approach minimizes the risk while allowing you to apply lessons learned from each implementation stage. So for company with substantial heritage and existing processes, focus first on preserving that valuable knowledge. And make sure your new solution can incorporate existing test sequences, test procedure, existing drivers, analysis function, rather than forcing you to start from scratch.
Yeah, as you're talking, I'm thinking about, I always worked in what we would call the legacy environment. I never had to deal with the problem of scaling up, and I think a lot of the things you're saying would have addressed it. That would have been a challenge, and I think that's a very sensible approach. But nowadays, I spend most of my time talking to startups, mostly to founders some of whom have worked a little in the business, some of whom haven't at all. And they have great technology, and it really does solve problems that people have. But they have very different challenges because this problem where your reputation is something is your competitive moat. It's very hard for someone, even with advanced technology, to break into a market where there's somebody who has a trusted solution. And so that's a very different situation than the one we were just talking about. For a startup that's in that situation where they really need to convince people that they not only have a great solution but one that can be trusted, how should they be implementing this approach?
Mm-hmm. Yeah. Clearly, startup truly face a different world. I work with one new space company that had built an amazing prototype with a team of great engineers. But when they tried to scale to just 10 units, they hit a wall. They had no documented processes, everything lived in the head of a few people, and they were essentially reinventing their approach for each build. So startups have a different set of challenges, since they're typically moving from paper-based or manually documented processes, if they do have some, to a digital production environment. So for these companies, I will recommend starting with first digitalization of their existing procedure before attempting to optimize them. So begin with the simplest implementation, taking your paper-based procedure and configure them in digital platform. And these immediate simple steps eliminates paper, provides basic traceability, and establish the foundation for future improvement. And then, after a few cycles with digital procedure, analyze the data to identify the bottleneck. For example, where are the operators spending the most time? Which steps have the highest variability? And it's this data-driven approach that is going to help you to prioritize where to focus improvement efforts. And once you've identified the bottleneck, evaluate automation opportunities. Could a simpler sensor or device collect data automatically instead of requiring manual entry? Or could a test equipment can be integrated to automatically record results? But I would say the main advantage of startups is they are going to implement best practice from the beginning without having to overcome existing processes. But however, they typically have more limited resources. So gradual implementation focus on immediate pain points, deliver the best return on investment typically.
Well, and they have to know that they need to implement best practices from the beginning, because in a startup, it's also really easy for not best practices to get ingrained really quickly. But let's talk about that in a sense. Let's talk about knowledge transfer for a second, because both legacy companies and small companies are going to have this problem. The legacy companies, the experience is probably getting pretty close to the door by now. They've been working there for a long time, but it takes a while to gain that experience, and you get closer and closer to retirement every time you do that. In small companies, the problem is that there's a very limited number of people who have any experience at all, and they tend to be moving up into higher roles in the company, and you're backfilling and hiring people below them. In both cases, the people who know these things are probably not the people who are going to be doing them a few years from now anyway. So how do you make sure that knowledge that's already inside the company can be diffused so that it can support scaling?
Mm-hmm. Yeah. This question, it's at the heart of what I've been here solving, Iain. Remember one painful situation where a senior engineer who had designed a critical subsystem retired just as the project was transitioning to production. It actually took decades of knowledge with him, and the team struggled for months to replicate testing and fine-tuning approach because it wasn't properly documented. Right. So knowledge transfer is one of the most critical and challenging aspects of scaling production. The prototype phase is dominated by design engineer with deep product knowledge, while the production involves totally different teams with process expertise. Right. So the most effective approach is using your INT platform as a knowledge repository from the very beginning of the prototype phase. Okay. And when designers start to develop test routine for component validation, everything should be captured in the same system that will eventually run production tests. And this is going to create a natural transfer mechanism. Maybe another effective strategy is involving production engineer early in the prototype phase. As the design moves from breadboards to engineering model, the production team should be part of the conversation, helping refine test sequences and procedure with manufacturing consideration in mind. Documentation of non-conformities and troubleshooting steps during prototyping is also incredibly valuable. And this often represents hard-won insight that will be extremely costly to rediscover during the production. So very important to ensure that they are captured in a searchable and accessible format. And finally, I would probably recommend structured knowledge transfer session, where the design engineer works production team through critical aspects of the product, particularly focusing on potential failure modes and testing approaches. And recording this session is very recommended because it creates reference material for future production team members.
Right. I mean, that brings up an interesting point too, is that this is really a cross-functional implementation. It's not just limited to one group. You know, you're talking about production and then testing. And again, in legacy companies, at least in small companies like mine, and production and testing were the same people. So that's an issue. But there's got to be other, in any organization of any other size, there's going to be other internal resources that are going to have to be involved to make sure not only that it gets implemented, but that implementation really sticks. So who else needs to be involved beyond the production?
Yeah. Since this transition succeed and fail based largely on how companies structure their implementation teams. By example, one aerospace manufacturers made the critical mistake of treating this as a purely IT project without involving production and quality team from the beginning. Right. The resulting system fails to meet anyone's needs effectively, and no one was satisfied despite the huge investment in CapEx. So successful implementation requires cross-functional involvement beyond just production teams. At the execution level, you need a clear vision and strategic alignment. The transition to scale production touches multiple departments and requires consistent leadership support. So within the production team, start to identify internal champions who understand both the technical requirement and also have the respect of their peers. And these champions become your ambassador and help to drive the adoption internally. Right. Obviously, IT need to be involved, particularly for integration with existing system, like if you want to integrate an ERP, a PLM, or another production tools. So they will help ensure that the data flows properly between systems and that the security requirements are met. Obviously, quality assurance team must be deeply involved to ensure that the compliance requirements are properly implemented in this new workflow. And the early input is going to prevent compliance gaps that could cause issues during the audits. Obviously, engineering teams, particularly the people involved in the prototype development, they are very critical for the knowledge transfer because they understand more than anyone the product's critical parameters and test requirements that must be maintained during the production scaling. And finally, don't underestimate the importance of involving the floor operator from the beginning, because they will be the primary user of the system and they can identify practical challenges that might not be obvious to the management or engineers. And their buy-in is just essential for successful adoption.
Yeah, you don't have to tell me that twice. Okay, well, we're getting close to time here, so maybe it's time to just ask you a little bit about looking ahead. You've been doing this for 5 years. You've done it several times, gotten stuff on orbit. But I know you're looking ahead as well. What are the innovations that you see changing how space manufacturers approach the scaling, in the future?
Yeah. But working across different companies in this space has given me a kind of unique perspective on where things are headed. And the manufacturers who are getting this right are actually already implementing some of these forward-looking approaches.
Okay.
So we right now are at an exciting inflection point for the space manufacturing. For example, digital twin technologies is one of the very promising innovation in horizon. Instead of building perfect individual components, companies will create digital models that evolve as real-world data is incorporated into it. And this allows for smarter assembly and matching components that work well together rather than requiring every component to be perfect. Right. Another one is probably AI and machine learning that will totally transform how we approach quality control and process optimization. Rather than just applying pass-fail criteria, these technologies will identify subtle patterns and correlation that human might miss, predicting potential issue even before they occur. And it could also help to determine which test points are essential and critical, instead of everything just because it's always been done that way in the space industry. And finally, the last one, but maybe the most important, I see a shift toward what some calls Industry 5.0, actually bringing human back into the center of manufacturing. So unlike Industry 4.0, focus on replacing human with automation, the future is more about using technology to augment human capabilities. And the automation should render routine tasks while empowering humans to focus on innovation and problem solving and continuous improvement. And it's really this human-centered approach that will be essential for space manufacturing, where flexibility, adaptability remain critical, even at scale.
Yeah. Well, I mean, thank you for all that. I just want to take a minute, if you'll allow me, and talk to the audience for a sec, because I really do want to tell you that with 40 years of experience in the last 5 years, spending a lot of time with startups and honestly with their investors as well, I need to emphasize that reputation really is the moat that cannot be crossed any other way. And so if you want to get ahead of your competitors, you have to build that reputation that they don't have. Now, you can do it the hard way by learning and making your own mistakes, or you can get there faster by working with somebody like Connectica, who's already seen those mistakes and knows how to correct them. The fastest way to get across that moat, which is your own reputation, I honestly believe this, is to use people who've made it their job to solve the really hard problems. Instead of thinking that you're going to solve them yourself, you probably could, but you won't do it in a way that will make you as competitive as dealing with somebody who already knows how to solve the problem. And that's why you guys should be talking to Connectica.